Now the next example in the exercise 3.4 on the repeated integral. Here example number 17, integrate the following with respect to x. Here 3 sin x minus 2 into cos x upon 5 minus 4 sin x minus cos square x. Okay, now we evaluate this integral. Here let integral is equal to, it is 3 sin x minus 2 into cos x whole to the upon 5 minus 4 sin x minus cos square x dx. Okay, now here see carefully, this integral is not in our type, that is not in the rational function. Okay, here it is 3 sin x minus 2 into cos x upon 5 minus 4 sin x minus cos square x. Okay, this is not straightly in our type, so the second step we can check there is a substitution or not. Okay, here in the multiple of dx there is a cos x, and cos x is a derivative of sin x, and here it is a sin, but here it is a cos square. So first we convert this cos square into sin. That means cos square x is equal to 1 minus sin square x. Now the all terms in the sin, and it is a cos x into dx, so here we put the sin x is equal to t. Okay, now first this convert cos x into the sin. Okay, see carefully this 3 into sin x minus 2 into cos x upon 5 minus 4 sin x minus 1 minus sin square x dx. And now this can be written as, see carefully, it is 3 sin x minus 2 into cos x and whole to the upon here minus, and this minus, so we can write here sin square x minus plus sin square x, it is a minus 4 sin x as it is, and here 5 minus 1, it is a plus 4 and dx. Okay, and now we put sin x is equal to t, because all terms in the form of sin, and it is cos x in the multiple of dx, so here will be substitution, that is a put sin x is equal to t. Put sin x is equal to t. Okay, therefore cos x dx is equal to dt. Okay, derivative of sin x, it is a cos x, and here dt by dx, so we can write cos x dx is equal to dt. And now our integral becomes 3t minus 2 and whole to the upon t square minus 4t and plus 4 dt, and then it is linear function upon quadratic function. Okay, here 3t minus 2 upon t minus 2 whole square dt. Here the factors minus 2, t minus 2 whole square, and now here it is denominator contains 2 repeated linear factors. Okay, here it is a rational function and denominator contains 2 repeated linear factors, and therefore we can write here 3t minus 2 upon t minus 2 whole square, and that is equal to a upon t minus 2 and plus b upon t minus 2 whole square. Okay, see carefully, and now take take the cross multiplication. Okay, we can write here. Okay, or we can write here, it is a into t minus 2 whole square and plus b into t minus 2 and whole to the upon. There is a, this denominator, it is a t minus 2 and t minus 2 whole square. Okay, when we take the t minus 2 common, one t minus 2 get cancelled, then this can be written, it is a 3t minus 2 upon t minus 2 whole square is equal to a into t minus 2 plus b upon t minus 2 whole square. Okay, here we take the cross multiplication. We take cross multiplication, and after cross multiplication in the numerator we can take common t minus 2. Okay, cross multiplication for the addition, then we can take t minus 2 common, and in the denominator there is a t minus 2 into t minus 2 square, so t minus 2 get cancelled, we get this. Okay, and therefore here it is a 3t minus 2 is equal to a into t minus 2 plus b. It is equation number 1. Now first we put this linear factor is equal to 0, therefore put t minus 2 is equal to 0, that is t is equal to 2 in equation number 1. We get 3 into 2 minus 2 is equal to 0 plus b. It is a 0, and therefore here 6 minus 2 4, therefore b is equal to 4. It is the value of b. Now here only one linear factor, it is repeated, so we put t is equal to any real number other than 2. For the simple calculation we put t is equal to 0. Put t is equal to 0 in equation number 1. Therefore we get 3 into 0 minus 2 is equal to a into 0 minus 2 and plus b, and b it is a 4. Okay, now here 0 minus 2 it is minus 2 and 4 we get here, for the LHS it is a minus 6, therefore minus 2a is equal to minus 6, and therefore a is equal to 3, b is equal to 4 and a is equal to 3 put in this relation, and therefore 3t minus 2 upon t minus 2 whole square is equal to a, it is a 3 upon t minus 2 plus b, it is a 4 upon here a upon t minus 2 and b upon t minus 2 whole square, and therefore integrate plus 4 upon t minus 2 whole square dt. Then this can be written 3 into integral of 1 by t minus 2 dt and plus 4 into integral of t minus 2 to the power minus 2 dt. Okay, here this can be written in the form. Okay, and therefore the integral is 3 into log of t minus 2 and plus 4 into t minus 2 to the power minus 1 upon minus 1 plus c. Then 3 into log of t minus 2 minus 4 upon t minus 2 plus c, and last answer put the value of t, therefore 3 log of sin x minus 2 and minus 4 upon, so it is 4 upon sin x minus 2 and plus c. Okay, here it is the last answer. Okay, see carefully. Okay, check this calculation carefully and write this step. Okay, here we take the cross multiplication. Okay, and after cross multiplication we can take the common t minus 2 and cancel the t minus 2 in the denominator, then we get this term. Okay, now see carefully this. Now we see the next example. Example number 19. 1 upon 2 sin x plus sin 2x. Now let integral is equal to, see carefully, it is 1 upon 2 sin x plus sin 2x dx. Okay. Now again here see carefully, such type of the examples we are already see in the our 3 non-repeated linear factors. Okay. There are, we use the formula for the sin 2x, that is the 2 sin x cos x, and then adjust the derivative in the numerator, and then we will get the denominator contains 3 linear factor. Okay. Now we see here it is here 1 upon here 2 sin x plus 2 sin x into cos x. It is the formula for the sin 2x. Now integral of 1 upon, here we take common sin x or 2 sin x. Okay, it will be here. Here we common this 2 sin x, then here it is 1 plus cos x. Okay. Now here it is 1 upon 2 sin x into 1 plus cos x. Now here it is a sin x, it is 1 by sin x, and it is 1 by 1 plus cos x. Okay. Here the sin x we can take in the numerator, that is the cosec, it is again in the standard form, but here we cannot take the cos x in the numerator. Okay. So it is in the composite form. Now here we put cos x is equal to t, and the derivative of cos x, it is a minus sin x. Okay, so we adjust the sin x in the numerator. Okay, so multiply numerator and denominator by sin x, then it is a sin x upon 2 sin square x into 1 plus cos x dx. Again put the formula of the sin x, it is sin x upon, it is a 2 into 1 minus sin square x into 1 plus 1 minus cos square x into 1 plus cos x dx. And now here we put cos x is equal to t, and therefore sin x dx is equal to minus dt, because the derivative of cos x, it is a minus sin x. Here we can write sin x dx, so minus can be in the RHS. Now here integral becomes sin x dx, it is a minus dt, that is minus 1 upon 2 into 1 minus t square into 1 plus t. Okay, here see carefully this, and now this can be written here this minus we can take the numerator, in the denominator it is a dt, that means 1. Here see carefully, we can write 1, therefore 2 into t square minus 1 into 1 plus t, or it is a t plus 1, and here dt. See carefully this minus can be written in the denominator, and therefore our integral becomes 1 upon 2 into t minus 1 t plus 1. Here it is a t square minus 1, okay, t square minus 1, or it is a 1 minus t square. 1 minus t square can also return 1 minus t, and it is a 1 plus t. It is 1 plus t, and here it is 1 plus t, there is a repeated. Now here we take this minus in the denominator, therefore it is minus 1 and it is plus, therefore it is a t square minus 1, and the factor of the t square minus 1 are the t minus 1, and it is a t plus 1. So okay, it is 1 plus t. 1 plus t can also, it is a 1 plus t or t plus 1, and here it is a dt. And now 1 upon this 2 we can take the outside the integral, and integral of t minus 1 into t plus 1 whole square dt. Now here denominator contains 3 linear factor, but the 2 are the repeated, that is a t plus 1. Now here it is a integral, and therefore we can write it is a 1 upon, we can only this 1 upon 1 by 2 as it is. It is a t minus 1, and here it is a t plus 1 whole square. This can be written a upon t minus 1 plus b upon t plus 1 and plus c upon t plus 1 whole square. It is a repeated linear factors. Now this can be written, it is a into t plus 1 whole square, okay, plus b into t minus 1 t plus 1 whole square, and plus c into t minus 1, and it is a t plus 1 and whole to the upon t minus 1 t plus 1, it is a t plus 1 whole square. In the RHS only t minus 1 and t plus 1, t minus 1 and t plus 1 square. It is a t plus 1 is extra, so we can take the common t plus 1, and it is a t plus 1 in the numerator and cancel it. It is a upon t plus 1 square, t plus 1 get common, plus b upon t minus 1 t plus 1, t plus 1 get common, here it is a square, we can write t plus 1, and plus c into t minus 1 and whole to the upon, it is t minus 1 and t plus 1 whole square. Now LHS and RHS denominator is same, so the numerator is same, therefore we can write 1 is equal to a into t plus 1 whole square plus b into t minus 1 whole square, sorry, t minus 1 t plus 1, and plus c into t minus 1, it is equation number 1. Now we find the value of a, b and c. There are the two linear factor, that is t minus 1 and t plus 1. In the denominator contains 3 linear factor, but 2 are the repeated. So finding the value, we put t minus 1 equal to 0 and t plus 1 equal to 0. Now here put t minus 1 is equal to 0, that is t is equal to 1 in equation number 1. See carefully. In equation number 1, we put t minus 1 is equal to 0. Therefore here 1 is equal to t minus 1 equal to 0. Here it is a t plus 1. Therefore a into 1 plus 1 square, t is equal to 1. Here t minus 1, it is a 0 and it is 0. Plus 0 plus 0, and therefore here 1 is equal to 2 square, that is a 4a. A is equal to 1 by 4. Okay, Now put t plus 1 is equal to 0, that is t is equal to minus 1 in equation number 1, and therefore we can write 1 is equal to, see carefully, 1 is equal to, we put t plus 1 equal to 0, that means the term a is equal to 0 plus term b equal to 0 and plus c into, when we put t is equal to minus 1, minus 1, minus 1, t is equal to minus 1, it is minus 1, minus 1, therefore it is minus 2 and 1, therefore 1 is equal to minus 2c, and therefore you can write c is equal to minus 1 by 2, it is the value of c. Now for the remaining value a and c, for the finding the value of b, we put t is equal to a real number other than t is equal to 1 and t is equal to minus 1. So here we put, for the simple calculation, we put t is equal to 0. Okay, here t equal to 0 ठेवलं तर सिंपल कॅल्क्युलेशन रे, t च्या जागा कोणताही किंमत ठेवा, कोणताही रिअल नंबर, फॉर द फाइंडिंग द व्हॅल्यू ऑफ b 1 आणि -1 सोडून कोणताही रिअल नंबर ठेवा, तुम्हाला b ची किंमत निघते. ओके, पण थोडं सोपं कॅल्क्युलेशन जाण्यासाठी काय करणार, t इज इक्वल टू 0 ठेवून द्या. नाउ पुट t is equal to 0 in equation number 1, therefore we get 1, this 1 is equal to a into 0 plus 1 square plus b into 0 minus 1 and 0 plus 1 plus c into 0 minus 1. Okay, here now to find the value of b, we can write here. Okay, for the finding the value of b, okay, for the calculation b, we can write here. Okay, now here it is a 1 is equal to a it is 1 by 4, 1 by 4 into 1, it is 1 by 4. Here it is a minus 1 into 1, it is a minus 1. Okay, that means it is a minus b, and here it is a minus 1 c, and c is a minus 1 by 2, so here it is a plus 1 by 2. Okay, and therefore this b we can write here, see carefully, 1 by 4 plus 1 by 2, 1 by 4 plus 1 by 2, it is a 3 by 4. Okay, therefore it is a 3 by 4 minus 1, this 1 becomes here, and therefore b is equal to 4, that is a minus 1 by 4. b is equal to minus 1 by 4. Now put the all values in this relation. Okay, now here see carefully this, okay, and write it. Okay, a, b and c. Okay, see carefully, we can erase this. Okay, see carefully, write down this. Now here therefore 1 upon t minus 1, it is a t plus 1 whole square, this can be written a upon a, it is a 1 by 4, 1 by 4 upon t minus 1 plus b it is minus 1 by 4, b it is minus 1 by 4 upon t plus 1. Okay, and c it is minus 1 by 2 plus minus 1 by 2 upon t plus 1 whole square. Now we find this integral, this replaced by this, and integral is equal to 1 by 2 into this, and therefore integral 1 by 2 into 1 by 4 upon t minus 1 minus 1 by 4 upon t plus 1 and minus 1 by 2 upon t plus 1 whole square dt. Okay, now it is 1 by 2 into, see carefully this, it is 1 by 4 into integral of 1 upon t minus 1 dt minus 1 by 4 into integral of 1 upon t plus 1 dt minus 1 by 2 into integral of, here it is a t plus 1 to the power minus 2 here it is square in the denominator, so we can write in the numerator it is a minus 2 and here dt. Now take the integrals. Here 1 by 2 as it is, 1 by 4 log of t minus 1 minus 1 by 4 log of t plus 1 minus 1 by 2. Here t to the power minus t plus 1 to the power minus 1 upon minus 1 and plus c. Okay, now see carefully, it is 1 by 2 into 1 by 4 take common, then it is a log of t minus 1 upon t plus 1. Okay, here the first two term, and here minus minus we take the plus 1 by 2 into 1 by t plus 1 and plus c, and last answer put the value of t, and t is a substitution, that is the cos x. Okay, t is equal to cos x. Therefore the last answer we can multiply by this, or we can again take the 1 by 2 get common, here 1 by 4, now here we can write 1 by 2 and here again as it is. Okay, here this 1 by 2 and here 1 by 2 we can take common, so here it is a 1 by 4. Okay, 1 by 2. Okay, and we can take the common 1 by 2 and here 1 by 2. Okay, 1 by 2 take common, here it is a 1 by 4 and in the bracket there is a 1 by 2 log of cos x minus 1 upon cos x plus 1 and plus 1 by cos x plus 1 and plus c. Now it is the last answer of this example. Okay, see carefully, check all the calculations carefully. Okay.